Uh, okay. Good morning, everybody. Welcome to our 10th workshop in preparation for our Colombia Bid Round 2021. We are already in the cycle number 2. Welcome to the people that join us first time. Well, as you know, we have already covered in our cycle 1, we covered the Caribbean, the Urabá, the Chocó, the Sinú San Jacinto, Lower Mac, Middle Mac, Upper Mac, Llanos, Eastern Llanos, and Pacific and the Pacific offshore. Those were the basins that we covered during our first cycle. And now we are in our second cycle. Last week we have the pleasure to have the DMAR group talking about the Caribbean and the Pacific activity that DMAR has developed there. And today we have the Cauca Patia with Enrique Cuervo as a speaker, and we have in the background Luis Vergara, Maria, and Rafael Acevedo, and Cesar Mora as well. I mean, for the questions that you address questions today, we will have all that the people asking answer your questions today. Next week we'll have the group of the UPTC talking about the Caguán and Eastern Cordillera. And on July 9th, we will have the Catatumbo. We have Dr. Ivan Olaya and our speaker, Daniel Rodriguez. We will have Guajira onshore and Guajira offshore on July 16th. And we will have Dr. Juan Carlos with us. We will have Putumayo the following week, July 23rd. And we will have also Ivan Olaya and our speaker, Arles Gutierrez. We will have the Cesar Rancheria on July 30, and that will be given by the agency, or speaker, Arles Gutierrez. And we will close the second cycle with the conventional and unconventional resources yet to find, and it's going to be given by Cesar Mora on August 6th. Juan Carlos Ramon is the last name of Juan Carlos. I'm sorry, Juan Carlos, who is going to talk to us on the Guajira onshore and Guajira offshore on July 16. Okay. So far, as I mentioned last week, we have 28 proposed areas by the agency and 4 nominated areas that you see in this black cycle, in 4 of them. So for a total of 32 opportunities so far for our bid round. Don't forget that you can nominate areas during this time until August. If you are enabled with the ANH, you can nominate, incorporate those areas. I mean, so that's the invitation. You can do that. But today I would like to mention something that maybe just to pay the attention call the attention of everybody. Within those 32 blocks that we are promoting this time, that the agency is promoting this time, there are 9 blocks in green color that have some direct hydrocarbon indicators, or they have what we call it already discovered reservoirs not developed, or those are areas that were produced in the past, and the areas were given back to the agency. So in other words, in those 9 opportunities, you find those kind of hydrocarbon indicators, and please pay attention to them, because that adds a plus for people interested in having the development opportunity and the upside opportunity. I'm going just to mention those opportunities very briefly. We have here the La Mocha Consuelo in the Lower Mac. We have Guamito La Pinta as well, and the Brillante well here. All of them producers of gas or oil or condensate in the past. We have also here the Nunda and Casica opportunities in the Upper Mac for gas. And we have here in the Llanos 5 of our 6 opportunities have a hydrocarbon indicators or already discovered reservoirs not developed. I mean, we have Alazan here in the north part, Alazan. We have Balay, we have La Casona, we have Vanguardia, and we have Cusuco, Pastinaca, and Guarniz. So in those areas, those specific areas, we can have around 13 million barrels and 32 BCFs there. I mean, so pay attention to those opportunities. Those opportunities are included in the presentation the presentation prepared by the agency. So please go to the website, download that information, because the specification of those opportunities are there. So that is my invitation this week. As I mentioned to you, next week we are going to have the UPTC group with us, a very robust, a very experienced group with us next week, and they are going to talk about the Eastern Cordillera, geological integration, evaluation of oil systems and prospectivity, and the group as well is going to talk about the Caguán Basin. They are going to make the title of the talk is Geological Integration, Evaluation of Oil Systems and Prospectivity. So we hope to have all of you next week with us for those couple of interesting talks. And today we have the pleasure to present to all of you the Cauca Patia mega area. The talk titled Evaluation of the Cauca Patia Petroleum System, and is given by Dr. Enrique Cuervo. Enrique is a geologist, graduated in March 26 in 1985 from the National University of Colombia. He is an MBA. He ran an MBA in the UTPB University of Texas Permian Basin. He has worked for several companies in his 34 years of experience. He has worked for Cosmos Energy, CGX Energy, Hess, Remora, El Paso, Oxy, and Petrocol. So don't forget that you can address your question through the chat. However, at the end, Daniel Rodriguez or key guy in the agency is going to lead the section of question and answers. But don't forget that your question can be addressed through the chat, and Daniel will cooperate with the group, with the speakers in solve or answer all the questions that you address. Welcome, and thank you for following all these workshops weekly by weekly. Enjoy the presentation, Enrique. Enrique? Enrique, we cannot hear you. The microphone, Enrique.
Oh, sorry, I have my microphone off. Good morning, everybody. Welcome to this presentation of the Petroleum System Evaluation of the Cauca Patia Basin. This work has been conducted by a group of professionals assembled by the UPTC, the Universidad Pedagógica y Tecnológica de Colombia, and prepared this work for the Agencia Nacional de Hidrocarburos, ANH. So the group is formed by myself, Enrique Cuervo, Carlos Julio Rodríguez, Oscar Castillo, Claudia Caicedo, Luis Vergara, María Teresa Cantizano, Germán Forero, Rafael Acevedo, César Mora, Juan Guarín, Patricia Chajín, and Antonio Rangel. Some of my colleagues are going to be present in this presentation to answer specific questions related to their special expertise. So you're welcome to address any question throughout the presentation and will be answered accordingly. So first of all, I'm going to outline the presentation. So we're going to talk about the regional geological framework, also the exploration history and some of the database that we have for this basin, the chronostratigraphic charts, paleogeographic maps, petrography of reservoirs and seals, seismic interpretation, structural models, modeling of the petroleum system and plate fairways, and finally, we're going to summarize and present some recommendations. Well, the regional framework is well known for many of the Colombian geologists and also for the international community. It's a very complex region. The Cauca Patia Basin is located in the northwestern side of South America in an area called the Northern Andes Block. It is located between the Central Cordillera and the Western Cordillera of Colombia. This is a polyhistoric tectonic basin with multiple phases that originated during the separation of the South American and North American plates by the mid to late Jurassic, and then the subsequent interaction of the Proto-Caribbean, Caribbean, and Nazca plates. The initial sedimentation is believed to be dominated by deep marine environments during the lower Cretaceous, kind of a passive margin that was followed by an active margin during the upper Cretaceous, and then a four-arc setting during the Paleogene time to finalize with the intermontane basin that now is constrained between the two Cordilleras that I mentioned before. Different tectonic uplifts were experienced during the Tertiary time. Most of these are associated with the interaction of the tectonic boundaries that surrounded this area and the accretion of the Panama Arch during the Miocene, late Miocene time. The basin is located, as I mentioned, right at the boundary between or at the northwestern side of the South American plate. And in this left map, I'm going to outline the two provinces. One is the continental cross, that is the arrow pointing to the right. And the other one is the oceanic cross, arrow pointing to the left. It is separated by a fault called the Cauca-Almaguer Fault. That is actually the eastern limit of the Cauca Patia Basin. The western limit, it is the fault Cali Patia. And the sediments, or rather the geology within the basin, is very interesting because the northern side is dominated by flatlands, especially alluvial and terraces. Down to the south, there is a scouring of the Tertiary down all the way down to the Cretaceous section. And this area is separated by the Popayan High, Paleo High. So this Popayan Paleo High divides the waters that drain to the north along the Cauca River into the Caribbean seas, and the Patia River that drains down to the south and then to the west into the Pacific Ocean. The eastern side of the basin, it is there is the Central Cordillera, And the Central Cordillera contains several rocks, which are the Jurassic to the some Paleocene rocks of the different metamorphic complexes. These are the sources for the detrital material that is forming the tertiary section in the basin. So these sections are the Amaime Formation, the Complejo de Arquía, right here in dark blue, the Complejo de Quebrada Grande, the Complejo Cajamarca, and the intrusive of the Jurassic rocks here. Most of these are the source for detrital material, again, to the sediments that we are going to explore in the basin. To the west, there is the Western Cordillera, is a mix of marine Cretaceous sections with igneous, mostly oceanic cross rocks. The basin is about 14,000 square kilometers in area. It has a length of 450 kilometers, and it is oriented about north 23 degrees east. It's a very narrow basin. The width, some areas can reach 50 kilometers in width, and some could be as narrow as 20 kilometers. Now, how the basin was developed is a matter of different opinions, but to summarize here and briefly go through this presentation, we are going to invoke the models developed by Pindell and Keenan in 2001 on the development of the Gulf of Mexico and the Caribbean areas. So the maps are sketches drawn based on Pindell drawings, and the locations basically are drawn on the PaleoMap project by the Scotties. Each map is going to have a location for a block diagram. In this left panel, we are going to see the A to B, and down here we are going to see the corresponding block diagram. We can start by the late Jurassic, when the South America and North America was experiencing this stretching in this northwest-southeast orientation, present-day orientation. And the Gulf of Mexico was already well advanced, and salt evaporites were being deposited. It's believed that part of the salts that we see in the Cundinamarca Basin in the Eastern Cordillera could have been developed during the same time, coetaneous with the formation of the evaporites in the Gulf of Mexico. That's debatable. Some other people believe that that salt is Cretaceous in age. So as the extension continued, the area developed the oceanic crust here in dark blue, which is the Proto-Caribbean plate. At the same time, the western part was dominated by the later Caribbean plate that is going to start acting during the Cretaceous and moving in the northeast orientation, passing kind of in a transform fashion the area of the Cauca Patia Basin. The Cauca Patia is always going to be located on these or indicated by the location of these dotted red lines. In the Aptian time, still the basin was kind of a deep marine passing margin, but it changes into a more active by the initiation of the subduction in the late Cretaceous. Subduction of this Caribbean plate started to be active, and some volcanic and intrusions started to appear at the late Cretaceous in the Cauca region, and also later on in the Central Cordillera. By the Maastrichtian, so seems that the Central Cordillera will start to uplift, and sediments started to be derived from the Central Cordillera into the foreland areas, the upper Magdalena and the middle Magdalena Valley, and consequently toward the west. So the west was initially uplifted. So, and then the first input of sediments, mostly plastic, alluvial type of continental deposits were developed over the current Cauca Patia Basin. During the Paleogene, starting the mid-Eocene, the basin developed into the forearc, and it is clear the distribution of sediments being very proximal, alluvial fan to the east, and progressively deepening up towards more distal to the west, and until reaching some coals and shore face deposits and some reefs like the Viges Formation that we'll later talk about during the Oligocene. By the late Miocene, the Western Cordillera was uplifted and the basin was constrained now between the Central and Western Cordillera, and the drain started to be divided toward the north along the Cauca River and to the south along the Patia River. The exploration history of this basin is intriguing because even though it's very frontier, it has some early activity in the 60s. So 5 wells highlighted here in these beige boxes were drilled around Cali area, in the area that we know as called the Cauca Subbasin. These 5 wells were, the first one was drilled by International Petroleum Company in 1965. It's called the Candelaria 1 well. That well encountered some gas shows, but it was no more information about that other than a few cores, 5 cores were taken. Then in 1997, Trinity Gas drilled 4 wells in the same region. It is claimed that some of these wells had some good shows, particularly the Patacori 1 well. And if we consult Edin from IHS, it says that the company at the time, meaning Trinity, reported have found good amounts of oil shows and gas shows. Unfortunately, there is no record that we could find to verify these claims. Finally, there are 14 core wells drilled by ANH during the 2010 to 2012 drilling program. 13 of these are slim holes. There is only one deep well, the Patia 1 in the southern part of the basin. There is significant amount of subsurface information, particularly lab analysis, petrophysical and biostratigraphical, thermochronological and geochemical analysis from these wells drilled by ANH. As I mentioned, there are 3 wells with gas shows in the area around Cali, in the Cauca Subbasin, and also down to the south in the Patia Subbasin. There is one interesting oil seep in the area that have attracted the attention of many explorers through the ages, and that is the Matacea. Matacea is a very intriguing oil seep that we'll describe later through the presentation. All the wells during the basin have been plugged and abandoned, and there is no commercial discovery so far. In terms of geophysical information, there are 3 areas separated by specific geographic conditions that have precluded the connectivity of the seismic data through the basin. So we have separated these in north zone, the central zone, and down to the south zone. There is these 8 2D seismic programs that accounts for 1,861 kilometers of 2D lines. In the north zone, in 2009, ANH acquired 293 kilometers. In the central zone, there is 3 programs, one shot in 79, the other one in the 80s by Ecopetrol or by Western for Ecopetrol, and that total 683 kilometers. There is an additional program shot by ANH in 2017 of 323 kilometers. In the South Zone, there are 4 programs, 2 shot by Ecopetrol, one with Western, one with Sismocol. The first one in 80 kilometers, the second one, 210 kilometers. Gran Tierra, which had a block in the south, they had 2 programs, one in 2013 of 175 kilometers, and another one shot in 2014 of 95.6 kilometers. In addition, there are some gravity data and magnetic data across the basin. And that is one, 2006, shot by ANH, is 4,795 kilometers, or aerial gravity and magnetic in the northern zone. And 2012, the ANH also conducted a program on the 2009 seismic lines. They had 1,243 stations. And finally, Gran Tierra in 2012 had 9,000 or aerial gravity and magnetic in the South Sound. In addition to this information, we were available to have access to 9 outcrop sections across the basin. Those were conducted by GeoStudies or GeoStudios in 2008. And also we consulted several papers. We are going to mention 2 specific ones from the Universidad de Caldas from Pardo and Trujillo. So let's talk about the stratigraphy, some chronostratigraphic charts, the paleogeographic maps, the reservoirs and seals. Being this basin as narrow as it is, it has a tremendous amount of phase changes across the length of the basin. And given, again, to the limitation of the accessibility of the outcrops, we have developed a plethora of studies which description that differs from one side to another, and this created a mix of stratigraphic nomenclature that we have to collect and then try to normalize or to standardize to create our chronostratigraphic charts as well as the paleogeographic maps. This table shows the age on the west in color boxes. And in the center of the chart, we can see the ranges given by different authors of the ages of the units that they study. At the top of this chart, there is the name of the author that proposed the different units that we are considering. In the work that we conducted, you're going to be able to find more information about the origin, the source of these different nomenclature. For this study or this presentation, we are going to show 4 different paleogeographic maps: the Paleocene, the late Oligocene, the mid to upper Miocene, and finally the upper Miocene to Pliocene. All right, so how we are going to put that? We are going to show first 4 chronostratigraphic chart, 1 along the axis of the basin, and 3 across the basin, 1 in the northern side, 1 in the central, and 1 in the southern side. Again, the northern side, north of the Popayan High, is called Subcuenca del Cauca, and the southern side, south of the Popayan High, is subcuenca del Patia or Patia subbasin. We are going to highlight whether the section has reservoir potential, silt potential, if they have affinity to gas or is prone to oil regarding the source rock. And for the lithology description, we are going to use common known legends for the description of the rock types. First of all, let's go to this chronostratigraphic chart that goes from south to north. And it's going to be very notable, pretty clear here, this separation of this gap that represents the Popayan High. So north of Popayan High is going to be the Cauca Subbasin. North is going to be the Patia Subbasin. The lower part, starting from the late Jurassic to early Cretaceous, we're going to put the Amaime Formation, which is mainly the basis on which this section or sedimentary section is developed, and is the oceanic cross, possibly a remnant of the Proto-Caribbean plate. Following that is going to be a mix depicted here in green with these, is a mix of sedimentary sections, mostly deep marine, intermixed with basalts and volcanic flows, and tremendously fractured. It's completely tectonized. It's hard to decipher the actual location and correlation of the blocks in the area. This is something that in the future probably will going to be resolved, but at the current stage is really difficult to assess the continuity of these blocks. All of this has been called the Complejo Estructural d'Agua, or the d'Agua structural complex. At the end of the Cretaceous, starting from the Turonian all the way to the Campanian, and perhaps during the Maastrichtian, there is more discernible stratigraphy, and is there where we have some of the most prolific and potential source rocks in the area. For this study, we're going to mention the Nogales Formation and also the Chapungo sequence. Also, the Chapungo is not official name. It has some interesting data for the source rock in the southern part of the basin. Soon after the end of the Cretaceous and the uplifting of the Central Cordillera, as we mentioned before, then it was a complete change in the stratigraphy and the composition of the basin, because now everything is more molassic. Before was more marine type of sediments. Now we are going to move into more continental dominated setting. Still, the location of these units is controversial, difficult to determine with exact position, given the lack of chronostratigraphic or biostratigraphic support. But most of the authors coincide with, there is a section at the base of the tertiary, which is the Monteloro, Chimborazo, and Peña Morada, which is alluvial fans, and some moving into the fluvial plains and intertidal deposits in the southern part of the basin. Then is a gap of the Miocene age, and then we move again into different cycles of alluvial deposition, given the fact that at the moment the Cordillera, particularly the Central Cordillera, is moving up and providing a lot of material for this section. We have to the north the Cartago Formation that has an expansion of since the Eocene all the way to the Oligocene, and it reaches the Miocene, the lower Miocene section. It's a very thick section that reaches a very wide time range. Moving south into the central part of the region in the Cauca Patia, in the Cauca Subbasin, we have some wells that could indicate what is the stratigraphy in the basin. And this is the Patacore well. And there we start to see some marine influence, especially in the Oligocene. Previous, in the late Eocene, we see a lot of coals, and the coal is located particularly in the western side of the Cauca Patia Basin, not in the east. So it is indicating that the basin was progressively deepening and towards more marine settings to the west. Finally, in the early Miocene, there is another impulse or penetration of the ocean around the area where this well, Cauca 17, is located. And there is aperture phase to foreshore deposits here in this region. So we can actually say that there was some marine dominated setting by the time in the basin. Finally, now the uplifting of the Western Cordillera, the increased activity of the volcanics along the Central Cordillera, so more input of volcanic tuff, volcanic material started to be included in this formation, La Paila, and then Vilela, Popayan, Galeon, and finally, the present day alluvial fans, terraces, and river deposits along the basin, particularly, or well preserved to the north, mostly eroded, and those remain as a perch terraces to the south. So now I'm going to go to these three sections, one to the north, one to the center, and one to the south, but I'm not going to dwell too much into it. Only going to refresh here that, to remind, sorry, that the section is very unknown in the subsurface. There is no information below the mid-Miocene that we can speak about. All the interpretation is based from acquiring the observations on the flanks of the basin and projecting into the basin. So again, we have the oceanic crust of the base, the marine environments at the upper part of the Cretaceous, and the molassic deposits of the tertiary section. If there is specific questions, we are going to try to explain as much as we can at the end of this presentation. We are going to move now into the central part. And this is more interesting because there are wells here, the Juga, the Candelaria, and also the Patacore wells. These wells, although the data exists, it is not very conclusive. The stratigraphy is not enough to make a clear distinction of what is the age of the formation. But again, we compile data from the flanks of the basin to try to complete this chart. We have the Juga drill only the Miocene, down to the Miocene, and then enter a Paleo high, which is a form of these Cretaceous volcanic rocks. The Candelaria drill a section of the Eocene, and also, which is known as the Paleocene Chimborazo Formation, and enter the Cretaceous. Finally, the Patacore was drilling in one of these gravens that we'll describe later, and drill a carbonate section down here that seems to correlate closely with an outcrop over the Western Cordillera called the Viges Formation, that is well established Oligocene in age. To the west, again, we see presence of more marine to lower delta plain deposits. And to the east, we're going to see more proximal alluvial deposits. That is the trend that we observed in the basin. I mentioned before this well, Cauca 17, and there are cores here which show that this is an aperture phase and foreshore deposits in this, which is called the Suarez sedimentita, the Suarez or sedimentats. Finally, to the south, we have one deep well, the Patia 1, it drilled down into what it is called the Peña Morada. Some authors disagree with that, but ANH information shows that the well indeed entered the Peña Morada, which is Paleocene or NH. The other wells in the area only drill down into the lower Miocene. Surface geology indicates that there is some coals, and there are several drilling for mining of the coal in this northern part of the Cauca or the Patia Basin here, with certain plenty of information about the coals. It shows again that the basin is progressively more distal to the west. It's kind of a present day Western Cordillera and the Pacific Ocean. So we have the Western Cordillera providing all the detrital material developed along the plains, jungle that form the Tumaco and Chocó basins. And then very close is the ocean. So it seems that that situation was very similar to what happened right here during this tertiary time. So the width of the present day zone between the Western Cordillera and the Pacific Ocean is about 50 kilometers. So very much the same as it was during the Eocene to Miocene time, west of the Central Cordillera at the time. So here it is. So on these maps, we can see, I'm going to make a clarification here. We put these maps in the context of present day cartographic coordinates, and also the location of the Pacific Ocean. It doesn't mean that it was that. This is not a palimpsestic reconstruction, but not to leave those maps floating in the air. So we put those landmarks. During the Paleocene, we have prevalence of conglomerates developed on these alluvial fans from the east, from the Eastern Cordillera and moving west, and then finding some of the alluvial and more shallow marine deposits in the Patia subbasin. To the north, fluvial deposits braided in meandering rivers, some of the conglomerates coming from the Central Cordillera on these alluvial fans. It's interesting that the prevalence of the sediment supply was always the Central Cordillera, because it was the only area uplifted. Could have been some local paleo high in the Western Cordillera. Those started to appear in the Oligocene. And that's what happened here in this map when we see the biggest reefs that are developed in this area. And in fact, those rest on top of the volcanic Cretaceous rocks. And perhaps some back reefs reach all the way back to the Patacore well. So the same type of trend existed from the north, for alluvial plains, braided streams, and also meandering rivers. Some alluvial fans, a lot of conglomerates in this area, drilled by wells. And down here to the south, from outcrop data and well information, we can see those alluvial fans, some marshy deposits to the west, and the development of some thin laminated coals. Finally, in the mid-Miocene to upper Miocene is where we start to see an advancement of the marine environment in the central part of the basin. We don't know if that happens, in fact, to the north, because there is no outcrops. But our rendering of this interpretation projects what was seen in the Cauca 17 to the north. And we see that the ocean pushed a little bit farther east the alluvial systems. And now during this time, we don't see these alluvial fans that were prevalent in the previous time. But the end of the cycle, right in the starting the middle of Miocene, but mostly in the upper Miocene to the Pliocene, with the eastern Cordillera, sorry, with the central Cordillera uplifted, and now the western Cordillera emerged, we would have expected more deposits coming from the west, but it is intriguing that seems that the supply of the western Cordillera was minimum. We see that most of the environment still persists from the east, from the central Cordillera, and this is only to the north. This is interesting because here we have one of the section, the thickest clastic section with best porosities in the region. This, and also this is called the Paila Formation, and one to the south, the Patia Formation. The area was interestingly plugged by the uplifting of ranges here, the Miravalle syncline range that happens here in the northern part of the basin, and also from debris coming from the volcanoes of the central Cordillera that regularly plugged the drain system that was taking sediments to the north. So that's why a lot of small ponds were developed, and some diatomaceous deposits are commonly found in this northern part of the basin. And it still persists, this plugging. That's why the Cauca subbasin is more flat and more alluvial deposits are preserved. Let's go to the reservoir evaluation. We have combined the surface geology from different outcrops and also data from the wells drilled through the basin. Here is an example of the Cartago-Alcalá section to the north. So, and this is the Cartago Formation. The Cartago Formation has a section in the middle, which we call Cartago Lodolítico, or mudstone section, which is about 1,200 feet of shales interbedded or mudstone interbedded with sand. That section was drilled in the Cauca 33 stratigraphic well. The correlation is shown here. And the composition of the rock shows particularly that the section, regardless of the section sample, if you look at the section that was sampled in the outcrop, is mostly from the sands above and below the shaly unit, but in the well is mainly from the unit. So still the analysis conducted by Corlap in this section down from the outcrop shows that is mainly a lithoronite, and also from the well, it is a lithoronite with some feldsparts that are still preserved in the well, not in the outcrop. So not much difference in composition. In terms of porosity and permeability, the left panel, this cross plot showing permeability from all the outcrop samples and porosity, shows a very wide distribution of values that we should expect that. But what is interesting are the green colors, the green squares, and also the dark blue and the purple. These are for the Guachinte Formation and also Chimborazo Formation. So those are the units that appear to be showing the best quality of reservoirs in the area. And if we go to the well data, the shallow section of the basin is showing a very wide distribution of values for the La Paila Formation. La Paila is this Miocene section that I mentioned before in the Paleogeographical Map. And also the Patia Formation, which is the equivalent in time to the south in the Patia Basin. It's extremely good, the values that we can see here in terms of porosity and permeability. The Cartago, the red squares, are not as good. And in fact, those have values less than 1 millidarcy in permeability and probably less than 10% porosity. Few samples can reach above it, but the dominant unit here, at least in this part, is Patia in purple and Paila in green. Paila also has some very bad quality, but it depends on what type of sample was analyzed. We'll go further on this later. In terms of well data and the quality of the logs that we evaluated, overall, I think most of the wells have sufficient information to be analyzed. Unfortunately, some of the key wells had some real troubling issues. The Patia, being the deepest well in the southern part of the basin, has some gaps with no data, perhaps is given by the fact that the well was in such a bad shape that the tools could not read, especially in this section. We have over 250, almost 300 feet of no data. In addition, there were some kind of intriguing and not very credible logs for some portions of this well, Cauca 17, in the square red here that we see. There is an unusual jump in the resistivity in an area that we don't see any changes or drastic changes in the gamma ray. It could be due perhaps to the bad shape of the well, and probably the tool jumped, or it was not a good reading. Also, it was notable to see that the separation between the neutral porosity and the density, the readings were extremely separated, even in areas that it could have been some sand. So some things to be considered for future analysis. Overall, if we plot all the gamma rays, we see that we got this log normal shape distribution for the lithology from the gamma ray. We could have expect perhaps in some more clean environments, we have more clean sands, some bimodal type of distribution. But here, what we see is that every sand has some content of clay, and we have low pure clays and low clean sands. Overall, we have up to 48, we consider these sands, and from 48 API gamma ray to about 80, we have some clayate sands. In terms of neutron porosity, there's a big concentration around 20 to 25. And in density, we have some bimodal with 2.6, perhaps some quartz, but unusually high values, very dense material above 2.7. This could probably indicate the heavy minerals coming from this oceanic crust in part of the basin. So the petrophysicists could identify some potential carbonates, sandstone, some gas in coal from the different wells that were analyzed. Since there is no information about the fluids of the wells drilled for purposes of water salinity, we try the normal methods like the Picket plot. And for this well, the Patacore 1 well in the interval that is shown here in blue, the formation salinity is about 24,000 to 30,000 parts per million of sodium chloride. So with that, and also with data that we were trying to collect from analog basins, and I'm going to mention here, we use Talara Basin some fields in Talara as analogs for the analysis of this basin. In absence of hard data, we use this analog data. So the first one, we try to analyze this section that was reported by the operator of the well, Trinity Gas, as well as 3 independent petrophysical companies to have pay. And these companies made this study in 1997. Those are HBC, Registered Engineers of Tulsa, Halliburton, and Diacomp. All of them found from the logs pay. So we tried to replicate what with the different cutoffs that we use: the big clay 30%, the water saturation 65%, and the porosity 5%. And in fact, it calculates pay. The upper section, the A section, which is the calcareous unit, has about, it is cumulative pay of different units of 38 feet. The lower part, the section B, should have 55 feet of pay. But this was very suspicious to us because nobody tested the well and there is no records, no final reports. So we went, and also we don't have any credible water salinity for this well. So we try a different run. And this one, we use 10,000 parts per million for the water salinity. And in this case, we have no pay calculation other than very thin strings of 1 or 2 feet of potential pay. So at this point, the calculation of pay is very unreliable. The lack of any testing of the well shows that the well did not have the potential that was reported by the operator. However, we cannot totally dismiss this information. It is something that we should continue evaluating, especially from the discarding samples. If there is any, we could add some studies and find more information. Now, in terms of the seals, as I mentioned before, there are several intervals with very muddy sections. In this case, this is the Patacore well. We use a kind of cutoff to determine whether this could be a seal. And based only on the calculation from the logs, we have an average permeability of less than 2 millidarcies and clay volume more than 60%. For this, we consider for this study that these could be candidates for sealing rocks. Here in gray, we highlighted those intervals in the well. Now, regionally, the section extends not only from the Patacore to the Candelaria, which are located right here in the center of the basin, but also goes farther north in the outcrop section of Cartago Alcalá and some of the wells that I presented at the beginning of the petrophysical evaluation. So this is really a likely source, regional source rock and source, sealing rock for the reservoirs located underneath it. And to the south, the same situation happens. There is a very thick section, more than 1,000, sometimes it has 900 to 1,200 feet of mudstones, and this could be very good candidates for regional sealing rocks in the Patia Basin. There are some other intervals that we can mention. In a local level for potential prospects, small prospects in this area, and from different reservoirs within the Huachinte Formation, there are several intervals that could have sealing properties, and those section exceeds the 50 feet thickness in this central part of the Cauca subbasin. As a summary for the reservoirs, we have put this table here coming from the different samples that have been analyzed. In light yellow are the samples analyzed from Antec, from the different wells drilled by ANH. And the dark yellow here, all the samples analyzed from outcrop data from Core Lab, and the study run by GeoStudios. Overall, the youngest section, La Paila and Patia, are really good reservoirs with permeabilities in excess of 300, 140 or 50 millidarcies, with porosities in the range, in average, about 17 to 14%. The Sedimentitas de Suarez, which is equivalent to Esmita, this is the upper shore face to foreshore. We found that very interestingly bad quality with low porosities, less than 5%, and permeabilities barely reaching 3 in average. The maximum is 25%. Cartago Cinta de Piedra is a formation that has no quality as a reservoir, or is very poor. So same happens for the Esmita. And long ago, I was aware of this region. Esmita was considered one of the reservoirs, but we didn't have any hard data at the time. But in fact, based on this data, Esmita is really not a target as a reservoir, at least from the data that we have. Mosquera in the Patia subbasin has a moderate quality for soft rock, those are sandstones. And Guachinte and Chimborazo. Guachinte has sections in the Los Chorros and La Cima members with good quality. The Loma Larga is moderate. And another unit that deserves more attention is Peña Morada, the lower section of the Patia subbasin that only has 2 samples. So there is not enough data to actually rank this. So it is indeterminate, but it could be better. Seismic interpretation and structural models of the basin. So we are going to talk about the data quality. The seismic data is really, really bad in some areas. We could not make any good interpretation along seismic markers because, as you can see here, for instance, we have 2 seismic lines in the Patia subbasin. The southern line, it really doesn't show much information. The northern line has a little bit more image that we can follow. And even if we have a good tie with the seismic on the well, taking those horizons away from the well is a big challenge. So we have to use some additional information. Here we have the gravity data, and that help us to put in context all the geometry of the basin. We can see in blue colors or cold colors deep the depot centers, and hot colors the highs, and the red lines are the faults, the outcropping faults. So it gave us at least a framework on how the basin behave in the area that we have seismic. In addition, we have some surface data, the satellite data. For instance, here we have an image of an area in the Patia subbasin. We have geological maps with very limited information. We make an interpretation on the seismic, in the satellite data, and overlap on the geological information, and we did not find a very clear correlation. In fact, there is still a lot of work to do in terms of cartography. But more interesting is that the seismic that is now interpreted based on these images from the surface, we found some very intriguing features. First of all, the Patia Basin experienced an uplift and erosion down along of this magenta horizon, and then it was a flat parallel deposition on top of that erosional surface. And later, a deformation of that section creating this syncline. Subcropping this section, there is these anticlines that we could not figure from surface geology. There is a lot of missing features that perhaps had to be evaluated with more detailed seismic data. This could be a target. In addition, this C formation corresponds to one of the youngest introduced formations, the Morales Formation, and the shaly section of that unit could be a seal or any truncations underneath it that could create traps, stratigraphic traps below. Some things to consider in the future. Now, in terms of converting the data to depth, we have to go through different process here. We have no subsurface data in the northern zone. So what we did is collecting the outcrop data from the maps and then trying to project those horizons in the subsurface and then assigning some velocity interval according to what it is known in the region of the velocities intervals for these different edges of different composition rocks. So this is very approximate model, but that is the one that we use to actually come up with maps that portray the depth of the section. Still very conceptual and not very, not definite. So the maps to the north, as I mentioned, based on highly on the surface geology. So you can see here the Western Cordillera, the Central Cordillera, the Patia in yellow and in gray, all the quaternary sediments. So we follow the same outcropping faults and try to project on the ground all the interpretation from the different lines that show some sort of continuity. This is the map of the basement that we put here is the limit of the Cretaceous and the Tertiary for this case. And also we have the map of the Cartago Formation. We couldn't find any four-way closures on this, but we found significantly large three-way closures that we'll talk about those later. In the central part, we have the Candelaria Formation. We have records from previous operators that indicated the velocity interval of the section in the well. So this interpretation particularly is based from Ecopetrol, Córdoba in 1998. This is for the Candelaria 1 well. The problem now goes into the well that is Patacore, because Patacore drill a section and there is no velocity data, but we have a synthetic seismogram. We tie the data as best as we could. But some of the horizons that were drilled in the Candelaria well were not drilled here in this well. So we had to project, based on seismic character, the location of those potential surfaces. Here, the Chimborazo and the KT limit. So for the central part, we created those surfaces in these gravens, for instance, for the Paleocene and the Cretaceous Tertiary limit that were drilled in the Candelaria, but were not drilled anywhere or nowhere in the basin. So this is pretty much hypothetical based on the thickness that the Eocene section has above the Chimborazo Formation and also the seismic character. It is interesting to see that there is some incisions right here at the base of the Oligocene that in some lines were pretty nice to see. And the onlaps of the infilling channel on the flanks of those incisions. On top, we have the Bijes Formation that was the carbonates drilled here in Patacore. Then we have all the Cartago section, the Cartago Inferior, the Cartago Lodolítico, and the Cartago Formation that we were able to follow. So these are the maps that we created for the central part of the basin. Then another example here is that the type of structuration of the basin, it was believed, and we consulted a lot of papers, many authors favored the idea of imbricated truss system, but in fact, we did not were able to replicate that interpretation, not only because of the seismic didn't support that, but because there is some wells that actually show some paleo highs indicated that there are some pores and gravens alternating across the basin, and particularly in this central part, there is a tremendously large, elongated, and narrow graven separated by two highs on the sides. The shoulders of those highs have been drilled, but some have some gas shows like the Candelaria one well. So these are the three maps that we can display here. The KT boundary showing that graben on the shallow sections on the flanks of that graben. The Guachinte formation that actually truncates against the fault and is preserved only on the graben, and few sections that appear in these uplifted blocks drilled by the Candelaria well. And finally, the section that fossilized the whole basin here, the whole Oligocene. This is the Miocene section, and it shows some interesting Fairway closures that we'll discuss in the modeling. Finally, the southern part, the seismic is, again, some difficulties. We have some velocity data for this well, the synthetic seismogram. We use the same methodology. We created the same maps. We use a lot the surface data and also the satellite data to come up with a plausible interpretation for these sections. So the methodology is the same. These are the maps from this mimics quite well the gravity data. Is a deep hole to the south and shallowing to the north for the KT boundary, for the Peña Morada likewise, and also for the Mosquera formation. It is interesting that these, there is a set of noses, structural noses against this fault in this central northwestern part of the basin that could be potential stratigraphic traps against an erosional surface. We did not consider those in the volumes because for the volumes we put quickly only the Fairway closures, but we mentioned those later on. And this is one line that displays those noses, particularly this one that has this star here, another one right here, but those plunge to the southeast and those are rising up to the northwest, and many of that interval is truncated underneath the Smita formation and eroded the uppermost part of the section. In addition, a lot of work was done to put together all the different sources of information, surface geology, seismic data, well data, and some of the gravity data to create solid models. Germán Forero created this in Petrel. So we have in the Patia subbasin, looking south, the model of the deep basin to the south, and looking north, the same block, illustrating the deep hole down to the south and shallowing up to the north. Here we have two panels indicating the noses, the structural noses that move toward the northeast. And here is the north view. This is the south view of those panels. And a section along the axis of the basin. So many vertical faults, the Western Cordillera to the left, and the whole section across the basin along the axis of the basin. The well, the deepest well drilling in this region, the Patia 1 STP. Across the section, across the basin, one section, again, same information. One interesting feature, we see that there is a thickening section previous to the Patia to the west, and that is inverted, and compensation started to happen during the Patia and the Galeon formation, where now the thickest section started to be developed to the east on the footwall of this bounding fault, which is the Taminango Mosquerillo fault. In the central part of the basin, same models. We illustrate the big ravine looking south, and the shoulders limited by vertical faults, rotated blocks. A view in the southeast orientation to illustrate the highs where these Juga and Candelaria wells were drilled, and also the Patacore drilled in the hole. Same section, just to show in 2D how the geometry of the basin looks like in this part of the region. Interesting here is not only that all of these sections for the Viges and the Cartagos are unlapping on the shoulders. It could be a very good possibility that this could create significant stratigraphic traps, but those require additional 2D seismic or 3D seismic data to actually map those potential traps. But those are possibilities that exist. In addition, the lower section that truncates against these faults could generate three-way closure traps, like in this area, for instance. This is a block diagram. There are block diagrams in the northern. This is the structural section for the Nogales formation in the northern area, more complex and not too many four-way closures. However, you can see this tremendously large three-way closure against the Cali Patia fault, something that keep in mind. And across the basin, or sorry, along the axis of the basin, this is based on the interpretation of a 2D line. So we have these several features pretty to represent how the interpretation was conducted in this part of the basin. And across, same, the Western Cordillera, the section of the stratigraphic section from the Cretaceous, and some location of the wells in this basin. Not to dwell too much into it. I'm going to go now into the geochemistry. This is a section that perhaps Cesar will explain much better. I'm going to go as fast, as clear as I can, but answers, or you can have all the questions and answers will come from Cesar. The basin has geochemical data from 16 outcrops located here on these pentagrams, and from 14 wells from these green circles. Most of the green circles represent data from the Miocene to the present day, very shallow sections. The outcrop data has the advantage of containing data from the Cretaceous all the way to the Miocene and Pleistocene. So we are going to, there is sufficient enough data for TOCs of all the samples, rock eval data, and some biomarkers for the oil seeps and some extracts. So there is plenty of data. And you can see that the data is concentrated down to the south. Not surprising, because there is the area that surrounds the oil seep of the Matacea. Although there are some oil seeps reported to the north, nobody has actually collected any samples or given some additional work on that region. What is the kerogen type? Here on this diagram, we can see that the majority of the samples are falling into the area that shows the kerogen type 3, type 4. A lot of the sections are immature. Most of these are from the Esmita Formation. And there are some that actually show a very anomalous, very high Tmax values. Few samples, and interestingly, this is the Chapungo sequence, are kind of outlining here in kerogen type 2. And there are some other samples that are following in type 1, but there is no information about those samples. In terms of the generation potential, it extends from very poor to extremely good. So interestingly, the section of the Esmita Formation, all the shales and organic material from that formation has a very widespread distribution, but very good section of that shows excellent potential for hydrocarbon generation. In addition, there is the Mosquera Formation. We'll go quick, in more detail later. And here comes the oil seep of the Matasea, one of the intriguing petroleum indicators in the basin. This is a gas chromatogram indicating the nature of this biodegraded oil. But it is interesting that since there have been more than one pulse, this one being already biodegraded, but the seep seems to be replenishing because it has some condensate section that actually is preserved, and these volatiles very quickly. However, in the samples taken, this section is well displayed. Where is the sources for these source rock? Or where is the source for this oil seep? There are some debates about what it could be. It might be that it is proximal marine environments with oleanan, and it could indicate some tertiary, but mostly some Cretaceous, like the Upper Cretaceous, Chapungo shales present in the region. So what is the expulsion rate for these, for the potential source rocks in the area? We have selected 4: the Chimborazo, the Guachinte, the Carbones, the Guachinte coals, and the Nogales Chapungo section. The thickness vary. For the first two, Chimborazo and Guachinte, is 50 feet. For the coals, is only 10 feet. And for the Chapungo and Nogales, is 100 feet. The TOC is 1.5 for Chimborazo, 5% for the Guachinte, 65 for the coals, and 3 for the Guachinte, sorry, for Chapungo and Nogales. Very low HIs for the first 2 units, and very high, or I mean, higher than 400 for the other 2 units. The summary here is that the Guachinte has very low chance of generating hydrocarbons. The expel could be 1.75 million standard barrels per square kilometer. The coals could be very high, at up to 8 million barrels per square kilometers. But the thickness is the thickness and the distribution of these coals are very limited in the basin. So although it is expected to be a source of potential hydrocarbons, liquid hydrocarbons, in fact, it is not necessarily one of the biggest targets because the limited distributions and presence of the coal. The Nogales and Chapungo, however, it is a source that could have a potential to expel up to 7 million standard barrels per square kilometer. And this is a section more widespread across the basin, or at least that's the perception. So the main source that we could invoke here are the Nogales and Chapungo, and again, with the caveat of the limitation, the Guachinte coals. The maturity of the basin is calculated for each section, one for different pseudo wells, one in the south, one in the center, one in the north. So the south, and everything is done based on transient heat flow. So using this methodology, the area in the south, in Patia, the Nogales is already in the, well, enter the oil window in the Paleogene and the gas window of the early Miocene. The Smita, which we mentioned has a very good potential as a source rock, is completely immature still in that region. For the Patacore in the central part of the basin, the maturity is good for oil for all the sections, including the Guachinte, Chimborazo, and Nogales, Nogales being the more mature to have entered in the early Miocene, and the Guachinte in the late Miocene. And for the northern part, the only formation that seems to be the source is the Nogales formation, and it is in the oil window at the beginning of the Paleocene and entered the gas window at the end of the Miocene. So the three areas have potential based on this thermal model of being mature, and also the indication of the oil seeps, particularly in the south, show that there are some mature source rocks. So the transient model uses this idea of a base temperature of the lithosphere of 1330 degrees Celsius and decreases all the way up to almost 5 degrees. Transient temperature, well, the calculation of the heat flow is given on this model, an actual heat flow on surface of about 53 megawatts per square meters. So for the Patia Basin, the Chapungo section had a transformation rate that shows that the section is actually having a transformation ratio close to 90%. And the expulsion efficiency for this formation is about 80% at the present day on this pseudo well. The Smita section has not even reached any of the transformation because it is immature. Excuse me. So the maturity maps, the bituminite reflectance using a maturity value or bituminite reflectance value greater than 6%, we have these green and reddish colors to see the maturity level. The blue colors indicate immature. The other colors is the mature section. The southernmost part of the section is already in the gas window, the orange and the red color. The pseudo well of the Patacore shows maturity only within this narrow graben that we outline in our structural maps. And finally, for the northern part, the Nogales formation would be mature in the or central eastern part of the basin, which is where the section is thickest, is the thickest. How is the migration pathways of these areas? So we have three surfaces here: the Peña Morada in the Patia subbasin, and also the Mosquera formation and the Smita sandstone. So the migration is very similar for each one because the geometry of the maps remains close related to each other, and we have four-way closures that make a cluster of potential accumulations down here to the part of the basin where we have the deepest part of the basin. It moves into gas as we move shallower in the section. But also, I mentioned earlier that there are some truncations that we are not displaying on this presentation or in the work. We didn't account for those. It could be a very large three-way closure against an unconformity, so meaning stratigraphic traps, in many surfaces in this southern part. Large in the Peña Morada, also persistent in Mosquera, and also in the Smith Arenacea. It seems that the section was uplifting, eroding, uplifting, and eroding. Uplifting accumulated sediments, then uplifting, and creating this persistent feature, something to consider for future exploration. The central part, given the fact that there is a very narrow section, not much oil is going to be available. However, if any, is going to be migrating from the depot center down there in the Chimborazo section and also to the remain Chimborazo in the Paleo highs or the uplifted blocks. Likewise for the Huachinte, but more ample for the sections to the north in the Cartago member. So the migration in the northern part, as I mentioned, we didn't find many Fairway closures, but again, there is this truncation against the Cauca Patia fault. A lot of migration is going into that truncation. So something to explore further in the future. So what are the potential fairways? We can outline the different stack potential reservoirs in the different units and come up with areas. In this case, the Patia Sur or the southern area fairway, which make this cluster of potential accumulations, and the Patia Norte fairway that shows less amount of features, but it's still very attractive. In the central part, this is the fairway for the Patacore region in the north, and includes three different horizons or potential reservoirs, and the Candelaria Fairway. The Candelaria well drilled a paleo high, but not in the highest part of the section. It shows some gas shows, but did not find any oil. And the Patia 1 well drilled on the side of one of these paleo highs. So we can say that these features are untested. And here again, in the Mosquera formation, the potential leads, we can highlight the fairway in the Patia Sur, the fairway in the Patia Norte, and the truncation that could be a very large potential accumulation. And here is for the Peña Morada, the potential accumulation south of the well drill, the Patia 1 stratigraphic well that did not drill this high. So how much oil has been generating in the basin? Well, this is always going to be a very debatable issue. We have to come up with an answer here, and the answer is assuming 100 of section for the Chapungo and Nogales formation and the TOC of 3%. Now we are going to put a distribution, a log normal distribution with different values from P10 to P90. In the south, the P10 is going to give 7.3 billion barrels of oil and P90 of 5.2 billion with a mean of 6.2. In the central is going to be smaller because as you have seen the narrow nature of the graben, the P10 is going to be close to 3 billion, the P90 2.2, and the P mean 2.5. And for the northern side, it's the 5.7 for the P10. The P90 is going to be higher than 4 billion barrels, and the P mean about 5 billion barrels. So these numbers are considered part of this exercise hypothetical based on whatever data we had, and hopefully future more accurate data is available to refine these numbers. Overall, what is the probable volumes of generated hydrocarbons in the region for and the Nogales. Well, total generated is 13.6 billion barrels, available close to 2 billion. Total prospective is going to be 250 million using a 13% chance of success. And the prospective recovery is 63 billion using a recovery factor of 25%. All these numbers, again, are hypothetical numbers. So in summary, I think we can say that there is an active petroleum system in the Cauca Patia Basin, the one very likely associated with the Chapungo Formation in the Cauca, sorry, in the Patia Subbasin that could have generated oil and could migrate into the potential reservoirs of the Mosquera Formation and the Patia Formation. In fact, this is an area that produces or is seeping some oil and gas. To the north, although there are reports of oil and gas shows in wells, gas shows in wells and seeps on the ground, we put this as a possible petroleum system in the central and northern part. But all the elements are there, and we think this is still an attractive area to explore for hydrocarbons, depending on the risk aversion of the companies that explore the region. I'm going to go quickly with some summary here. The presentation has been long, so there is a lot of summary points. I'm going to read some and escape others, but the main point is that the Cauca Patia Basin contains all the geological elements to make this area attractive for exploration. There are active oil seeps potentially generated from late Cretaceous and Tertiary source rocks. The main source rocks are the Nogales, the Guachinte, and the Chimborazo Formation, being the Nogales and the Chapungo the most attractive and the most likely source for economic accumulation for hydrocarbons in the region. Good reservoir rocks across the tertiary section, and potentially good sealing rocks regionally and local across the region. A structural configuration is mainly a transpressive setting with multiple tectonic events that has created potential for four-way closures and three-way closures event faults, and also erosional features that create subcropping traps underneath unconformities. The sedimentation during the 4-arc phase still maintain a dominance of proximal sediment, proximal environments to the east and more distal to the Patacore is one well that is very interesting to evaluate because it have intriguing points of potential shows, but more work has to be done. The interpretation that you have seen, this is a frontier basin with limited quality of information, is highly conceptual, but is based in our experience working with in frontier basins, and also gathering every source of information available to make the most concise presentation of this basin to understand what the potential might be for exploring the Cauca Patia. I'm going to go with the seismic interpretation. There are the three distinctive areas: the northern, the central, and the south. And you have seen the different quality of the seismic and the limitations, but the effort to create a compelling exploration story for this basin based on real geological data. The the statistical analysis for the volumes generated in the basin indicate that there is about 4.2 billion barrels in the Patia Basin, 2.5 billions in the southern part of the Caucasus Basin, and 4.8 billion barrels for the northern part of the basin. The resources generated, again, those are hypothetical numbers. The highest exploration risk in the basin is the current impossibility to determine the presence, quality, extent, and maturity level of the generating rocks, especially of the Cretaceous. We have to be clear about that. We know there is a very good hint that the Cretaceous is a good source, but we are not able to map consistently this surface across the basin. Well, this is not as strange in a region like Colombia, where we have explored for years and found oil, like in the eastern part of the Eastern Cordillera, where the data was completely impossible to interpret, but yet large amounts of oil have been found along that trend. Another great exploration risk is concentrated in the inability to make those reliable maps. But again, that's something that we explorers have to face. We don't live in a perfect world, and we have to make the best out of the data that we have. So the recommendations are, we have to come up, and Miguel was explaining to us that the ANH is engaged in a continuation of studies, and one of those could be trying to standardize as practical as possible the nomenclature stratigraphy of the basin, organize the database. That it is an effort that I know the agency is now carrying out, evaluate potential cuttings of existing wells to see if we can derive more information to improve the results of these studies. Make a detailed stratigraphic surface of the Cretaceous along the edges of the basin to determine the regional potential of this source rock, and also improve on the acquisition and processing of the seismic data. So with that, I really want to thank everybody to have endured these 2 hours of presentation, and to the colleagues that have put all the effort and time to make this work possible. To thank also the UPTC and the agency for the opportunity that have given us to this work. Thank you very much.
Well, Enrique, thank you for your amazing presentation for the whole Cauca Patia, the challenges that we got into the basin, and as well the whole information that is available, and the way that you have with the group that you have been into, the way that you have studied the whole basin, and give us this amazing, sincerely, this brilliant presentation today. So I'd like to thank you for being part of this project, for this, again, for the presentation. As far as I was aware of the chat, I didn't see any question. So maybe I'd like to give to the attendants a couple of minutes, maybe if they have a question that they would like to ask to Enrique. If there are no any questions, well, we will give Miguel. Yep.
No, just maybe taking an advantage of the presence of Luis Vergara, Cesar Mora here, and Rafael. If we don't have any questions, I would like maybe to invite Luis and Cesar and Rafael to comment on what is their view on the basin. I mean, and from the prospective side, I mean, we would like to invite them to talk about and give us some key concepts. Luis.
Well, yes, thanks, Miguel. I think everything was said already by Enrique. Made a very compelling presentation of what data is. It is what it is. It's very difficult. It's a very difficult basin. The stratigraphy is quite unknown. seismic qualities like it was shown. I mean, Enrique did a very good job pointing out towards the risks, the uncertainties, and yeah, well, it is also a place where you know, players, not necessarily for major players, but for small companies could be very interested in coming in and fill the gaps. There are many gaps where small companies can see opportunities and go in. There is potentially pay on those wells, but it's pointed out impossible to prove at this point because we lack a lot of data. But it wouldn't be very surprising that we are sitting on discoveries in those wells, at least in the Patacore, that has been overlooked. And again, if we get all the data that is missing and the reports that we never found, and somebody's willing to pick up acreage and re-drill or twin one of those wells, there could be some good surprises over there. But again, it's difficult. It's a difficult area, but lots of complexity. But exactly there's where the opportunities are. So it has been a very interesting project, and we learned a lot. And we updated a lot of things that were unknown of the stratigraphy, the structure, things like the Polyhydropopayan, very poorly or scarcely defined in the literature or nothing. So yeah, there's a lot to do there, of course, and yeah, I think it's a very interesting area after all.
Thank you, Luis. Cesar, would you like to add something else?
Yes, Miguel. I believe that when we put everything together, as Enrique mentioned, the main province, geological province for me, in terms of exploratory opportunities, is the southern part, the Cauca area. I believe that there we have an active petroleum system. We have reservoirs, and we have oil seeps, and we have some opportunities there. Probably for small companies, that's true, but if we discover some oil there, that will be very good for the country. I believe that the next step in the basin must be in the southern part.
Thank you, Cesar. Rafael, would you like to say something?
Yes, thank you, Miguel and colleagues. My comment is regarding the seismic quality. A lot of reprocess studies has been done by the ENAs and some companies that operate blocks here. Main issues are related with the quality and the type of seismic that we acquire. Because, for instance, in the middle part of the basin, the Cauca sector, we have a lot of vibro seismic. So probably new techniques of reprocess that are 100% to this kind of data. Also, at the south, we have a lot of dynamite information. So probably new techniques like CRS reprocessing techniques that I think probably helps to decrease the noise in this kind of data could be performed. So I mean, probably the main activity for new companies interested in these blocks could be started with a higher or a better reprocess techniques in focusing the kind of data that are available. Thanks.
Thank you, Rafael. We have Germán Ponero here as well from Canada. Germán, you want to add something to the topic? Germán? Well, Maybe Germán is not. Yeah.
Yeah, I'm here. Good morning, everyone. No, the only thing that I pointing out is the complexity of the structure. That's Rafael mentioned. One of the issues is the quality of the seismic. But if we can improve the seismic image, I think we can solve the structural complexity and understand in a better way the distribution of the reservoir and the traps that we can see in this area. I think one of the main targets for the future exploration is to try to improve the seismic lines, the seismic acquisition, the seismic images in order to get a better interpretation for the structural, because it's very interesting. The structure is very, very interesting. Thank you.
Thank you. Okay, Daniel, we are all you. I mean, you want to close the meeting? Thank you.
Yeah, well, for the closure of this Cauca Patia session, I'd like to thank again Luis for that concept that he had about maybe how the small companies can fill the gap into the basin in terms of acquisition of information that fortunately will try to help us to understand a bit better the structural complexity or even the seismic acquisition, or even how the petroleum system, since we are trying to find the Cretaceous source and to understand it a bit better, could help us to certainly try to figure out what's going on with this basin that certainly, despite the fact of being like with exploration since the beginning, we have some sort of it's underexplored. And I'd like to thank again for Enrique and Germán and Rafael and Cesar, of course, for the concepts and how they are trying to give knowledge, try to integrate the whole information that I hope all the attendants today have just that they could take it to their homes and try to know that this is a challenging, but the whole challenge bring with them amazing opportunities. And that will be the closure for today. Again, thank you to everyone that is here today. So see you next week with Cordillera, and the 9th of July with Catatumbo. Thank you, everyone. Thank you, Miguel, and see you next week.